Right, okay, so now what we're doing is we're moving into our next model. Remember in the previous week I was talking about this specific factors model, and it was a gentle kind of introduction to this Heckscher-Ohlin model that we're going to be looking at over the next couple of weeks. And again, it's just a move towards a more realistic version of a trade model where now you've got different factors of production, and we can now look more at this issue of the distribution of income. However, in this video, we're just going to introduce the model just to show you some issues about factor substitution and things like that, and then in subsequent videos we'll develop the model from there. Okay, so we're looking here far more at the issue of the relative abundance of factors. What we're going to see over the next few weeks is how important this is in terms of countries' comparative advantage, and how that is often dictated by this relative abundance in terms of resources, factors of production. So we know that from previous topics when we were looking at labour productivity in terms of the sort of Ricardian model, that's that countries, there is evidence of trade being or trade directions, if you like, being dictated by labour productivity. But there are also issues in terms of the direction of trade being dictated by differences in countries' resources. Now, in the first lecture, I think, I popped this little thing up, and it's not majorly important or anything. This just essentially is a nice little graphic that shows the major export for pretty much, I'm just trying to see if there's a gap, pretty much every country in the world. Some of them are very hard to see, of course, and we're not suggesting that these are the only goods and products and commodities that countries export at all. This is just by dollar value. These are the major ones. So you can see here Australia's got coal, a lot of oil around here in the Middle East, etc., and up into Russia. Europe, even though this is a bit hard to see, this is mainly manufacturing type things. You've got motor vehicles, obviously, in Germany, capital goods in the US, and so you can, and whereas in Africa here, you can see it's all primary commodities. I think that's true every single country. Yep, their main export is of a commodity. So obviously these reflect resource differences at a very basic level. I mean, you can't export crude oil if you don't have any crude oil, right? So we're going to sort of, not that we're going to be talking about raw materials and minerals and energy, etc. in this video, but this is the sort of thing we want to start looking at. So in terms of the basic model, it's what we call a 2x2x2 model. Should be very familiar to you by now. We've got two countries. We'll just imaginatively call them home and foreign again. Two goods, cloth and food. And now we've got these two factors of production, labour and capital. Now, ultimately, we're going to assume that these factors of production are mobile across sectors, right? So in other words, you can move your labour and capital. So this is one of the differences from the specific factors model between the two goods. Each good has a production function in its sort of basic form. Quantity of cloth is a function of the capital used to make cloth and the labour for cloth, and same for food. A little bit more notation, but again, should be relatively familiar to you. We've got the capital used to produce a unit of cloth, a yard of cloth, and obviously the labour used to produce a yard of cloth. And then the same for food, capital used for food and the labour used for food. So we'll use that a little bit as we go through. So in this model, the mix of inputs can change, and this again is a recognition that any particular good can be produced with a mix of inputs. You can use a lot of labour and a little capital to produce a good, or alternatively a lot of capital and a little labour. And this is ultimately where we are going in terms of this model, but actually we're not going to start quite there just yet, okay? And we will look at how countries do use these, or how they use their mix of inputs. But at the moment, to make things simple, when we're just sort of introducing this model, we're actually going to assume no factor substitution. So in other words, this is labour and capital are used in fixed proportions, yeah, for the production of each good. So if you're making cloth, we assume that there's a certain amount of capital that you need to make a yard of cloth and a certain amount of labour, and ditto for food. I'm going to give it some numbers just to make it, a little bit more tractable, if you like. So you can see here in terms of cloth, takes 2 units of capital, 2 units of labour, and for food, 3 units of capital and 3 units of labour. Now we can use this, I've also given us a constraint in terms of the total amount of capital in the economy and the total amount of labour, which we'll use in a minute. Now notice here we can use these to look at our relative intensity of factors. So you can see in terms of the food, for example, it takes 3 units capital and only 1 unit of labour to produce a unit of food. Whereas in terms of the ratio, if you like, or the relative use of factors for cloth, it's 2 units for each. So what that means then, and this is in terms of relative intensities, the production of food is relatively capital intensive, uses more capital per unit, uses more capital than labour, certainly relative to the production of cloth. And so if you've only got 2 goods and one, the food, is relatively is capital intensive, then by definition the other one's going to be labour intensive. Again, that's one of the benefits of just using a 2x2 kind of model. If there's a relative intensity in one, then the other the other good has got is relatively intensive in the other factor of production. Now, of course, I put up those constraints before. Can't exceed the total supply of resources. At this stage of the game, we're only talking about we're talking about one country at the moment, and so a country can't sort of import capital or labour, etc. So what we've got here is this amount here is going to be, so this is the production of cloth. You multiply that by the units of capital you need to make that, and that's obviously the total capital used in cloth. Then you can see here we've got the quantity of food being produced multiplied by how many units of capital you need to produce it. That has got to be at least equal or less than the total amount of capital available. Right? You can do the same thing for labour. Okay, so there's the labour used for cloth. There's the labour used in food, which must be less than or equal to the total amount of labour available. This introduces a constraint, means that we can't go beyond that. So this expression here, for example, let me just get my pen out. This one here, you can see again, I won't go back to the numbers, but remember it was 2 units of capital to produce 1 unit of cloth and 3 units of labour. 3 units of capital to produce 1 unit of food, and the same for food. So the same for labour. Okay. What we're going to do is we're going to take those constraints, we'll graph them to get basically our production possibility curve for this particular situation. There we go. Excuse me. So again, you see I've got food on the vertical, cloth on the horizontal. Here is our capital constraint. Here is our labour constraint. We want to plot this. So in terms of cloth, remember if we've got 3,000 units of capital all up, and it takes 2 units of capital to produce a unit of cloth, a yard of cloth or whatever I called it, then obviously at most we can produce 15 units of cloth. All right? So what I'm doing here is I'm graphing the capital constraint, then I'm going to graph the labour constraint, and we'll use that to construct the production possibility frontier. In terms of food, remember it took us 3 units of capital to produce 1 unit or calorie, I think I used, of food. So if we've got 3,000 available, at most, if we devoted all of our capital to food, then we can produce at most 1,000 units of food. Yeah, join the dots for those, and that's our capital constraint. And we can do the same, and the slope, of course, is just that ratio. We can do the same for labour. So here you can see for cloth, we've got 2,000 hours of labour available. It takes 2 hours to produce 1 unit, then at most we can produce 1,000. Do the same for food. We've got 2,000 hours, takes 1 hour to produce a unit of calorie of food, so we can produce 2,000. Now what you can see here is we've got two constraints, or two budget constraints. I can't call them budget constraints, but it's a similar sort of principle there. Now what we need to do, and there's the slope of the labour constraint line. What we can do here is we need to work out what our actual production curve is going to look like. So take all that stuff away. Again, I'll just put the two constraint conditions there. And the thing about this is that the constraints are binding. Okay, in other words, the production possibility frontier is bounded by both constraints. Now, what I mean by that is this. So if you produce only food, right? So let's focus on this one here. You can produce at most 1,000 units, remember? Okay. Now the reason for this is that remember, if you're producing food and you therefore need to use 3 units of capital, that means you can at most make 1,000. But if you think about it, if you can at most produce 1,000, because that's the constraint on the capital side, if you think about the quantity of labour that is required for food, remember you only need 1 hour of labour. Remember, these are in fixed proportions. Yeah, so 3 hours for capital. If you use 3 hours of capital, you use 1 hour of labour to produce a unit of food. That actually means we've got kind of unemployment, if you like, because even though it appears as though the constraint is 2,000, you physically can't use 2,000 units of labour here because you don't have enough capital, right? So that's what we mean by we say that it's binding, it's bounded by the physical amount that you can produce. Here the constraint is on the capital side, and we're going to have sort of 1,000 hours here. The difference between here and here, we're going to have 1,000 hours of unused labour, right? But there's no getting around that, because we simply can't use that labour anymore to produce any more food because we've used up all our capital, nor can we use it to make cloth because we've used up all our capital. We have no more capital, and again, to make cloth you do need some capital. Remember, they're in fixed proportions. So that gives us sort of one constraint, if you like. The other constraint on the other side is that if you produce only cloth, so we're looking down here on the horizontal axis, you can produce at most 1,000 units of cloth. Why is that? Because if you look at the labour constraint, remember it takes 2 hours to produce 1 unit. If you've got 2,000 hours, if you put all of your labour into cloth, you can only produce 1,000. Again, you've got unused or spare capacity in terms of capital, right? You're not using all of your capital resources. But again, because of that constraint, you can't. You're using all of your labour and you'll have spare capital. So what that means, though, is that these areas here, sort of here and here, are unattainable. Because we're using these things in fixed proportion, they're unattainable. So the budget constraint, or stop calling it the budget constraint, the production possibility is bounded by what is possible here. I'm using red on red, that's pretty stupid. And so on that part of it, and then on this part of it as well. So that's our PPF. Oh no, I want to get rid of that. And moreover, I guess I need to mention this point here where the kink is, where the slope goes from here and then down, this is actually the only point where we have no unused resources. All resources are going to be employed, and you can actually plug in the numbers here to see that we're going to be using all of our labour, and only at this point we're going to be using all of our labour and all of our capital. Anywhere else in terms of this PPF, we're going to have unused or spare resources. Now that's fine. As you can see, that PPF is not a straight line. It has that kink in it, and that's a reflection in a very basic way, because of the fixed proportions, that the opportunity cost of cloth in terms of food is not constant. So it changes its slope, obviously. Let me just go back there again. Changes its slope, obviously, here and becomes steeper. So it's not constant over the whole range. Now, basically, it's a very simple thing then to expand it to a sort of a non-linear production possibility curve. And all we've got to do is say, right, let's get rid of this fixed proportions production function. You know, the 3 units of capital and 1 unit of labour gives you a unit of food. So let's say that you can now substitute labour for capital, right, within each good. So that gives you, so that was the old one, if you like, there was the straight and the kink there. All we're doing is simply a reflection that we can actually substitute, change the mix, if you like, of proportions in terms of capital and labour. And that's what gives us that sort of more rounded, normal looking, if you like, production possibility frontier. So then the next question, of course, is that if we've got this production possibility frontier, what's the country actually going to produce? And of course, as it usually does, it depends on relative prices. So let's have a look at that. Before I show it to you, we want to just introduce a bit of a new concept, if you like. We're going to incorporate what we call these ISO value lines. I guess it's analogous really to ISO cost lines that you might have seen, I don't know, second year micro, something like that. And the value of production is, of course, pretty simple. It's there's the value of production cloth, there's the quantity of cloth you're producing, multiplied by the price you're going to get for it, gives you the value of that, and then you do the same for food. And so that will give you a certain amount, if you like, a certain value in terms of your production. We assume along an ISO, remember anytime you see the word ISO, it means that along each line, the value is the same, the value is constant. Yeah. And so in terms of this, and again, as with other kinds of ISO lines, ISO cost lines, etc., the value increases as you move out. The slope, of course, is the ratio of the prices, which you can get from this thing here. Okay, so this should be reasonably familiar too. It's a ratio of the prices of cloth relative to food. So each point on, say, this V0 ISO value line gives a certain value of production. V1 gives you a higher value of production. V2 even higher still. But as with these things, of course, this V2, this value, any combination of food being produced and cloth being produced is not attainable. Right? You don't have the resources to be able to do it. It lies outside the production possibility frontier. Anything within that, so for example V0, sure, that gives you a certain value, but you could do better, right? So a point there, you've got it will give you a certain quantity of food, certain quantity of cloth, but you can actually increase the value of your production given the resources that you've got. And so of course that leads to this idea that this is the optimal point here, that given the prices of food and cloth and the relative price of food and cloth, this economy is going to produce that much food, QF1, and that much cloth, QC1. And that's how we can sort of, the slope, if you like, of this, which is the relative prices, will dictate where the optimal point is for the economy. You can change the slope of that by, of course, changing the relative prices, and that's actually something we're going to do in a subsequent video. Another way of expressing this is point A here. Again, remember the slope of a production possibility curve is the opportunity cost of cloth for food in this case. And so the slope, any 2 lines at a tangent, all that kind of stuff, is that at this point here and only at this point here, A, the slope, the opportunity cost of the PPF is equal to the slope of these ISO value lines. In other words, the slope being the relative prices. So that's just an introduction to this. We're obviously going to take this a bit further in subsequent videos. In particular, given that we've got 2 factors of production now, we actually want to talk a little bit more about the price of these resources, wages for labour, and the rental rate of capital. And so that's going to be the subject of our next video.